Welcome to our exploration of Wi-Fi, a wireless adaptation of the Ethernet protocol that has become an essential part of our interconnected world. Wi-Fi enables us to connect our devices to the internet and communicate with each other without the need of a physical cable. It is based on the IEEE 802.11 set of standards, which establish the Layer 2 protocol for wireless networks. Wi-Fi, short for wireless fidelity, operates by utilizing radio waves to transmit data between devices and the wireless router or access point that serves as the central hub for the network. This technology allows smartphones, laptops, smart home devices and more to connect to the internet and interact with each other seamlessly. The IEEE 802.11 standard, initially developed by the Institute of Electrical and Electronics Engineers in 1994, defines the protocol and mechanism for wireless local area networks. It forms the foundation for Wi-Fi networks and ensures compatibility and the interoperability among devices from different manufacturers.
In comparison to Ethernet, which governs cable-based networks, Wi-Fi introduces unique challenges due to the shared wireless medium. While Ethernet collisions can be easily detected, wireless collisions require an avoidance mechanism to achieve a fair and efficient channel access. When stations are prepared to transmit, they initiate a random countdown and monitor the channel for ongoing transmissions. If the channel remains idle during the countdown period, the station proceeds with transmission. However, if the channel appears to be busy, the station defers its transmission until the channel becomes available, continuing the countdown. This collision avoidance mechanism, which is more intricate than the one used in AloaNet, ensures enhanced efficiency and speed. The IEEE 802.11 standard has undergone significant evolution over the years to support faster data rates, extended range, and improved security. Different versions of the standards are denoted by a letter followed by a number. For example, 802.11b was one of the earliest Wi-Fi standards operating in the 2.4 GHz frequency band with a maximum theoretical data rate of up to 11 megabits. Subsequent versions, such as 802.11g, improved data rates of up to 55 megabits. Notably, 802.11n introduced a more sophisticated antenna technology called MIMO and can achieve data rates of up to 600 megabits or even higher. The latest standard, 802.11ax, also known as Wi-Fi 6, operates in both the 2.4 GHz and the 5 GHz frequency bands. It introduces advanced coding technologies like OFDMA and MU-MIMO to enhance efficiency, resulting in speeds reaching 9.6 gigabits per second or even higher. While Ethernet and Wi-Fi speeds are comparable, the wireless medium is more sensitive to interferences and efficiency reductions compared to a wired Ethernet connection.
The architecture of Wi-Fi comprises key components, including the access point, or AP, which serves as the central connection point for Wi-Fi devices. The AP acts as a wireless switch, facilitating communication between wireless devices and the wired network, granting access to the internet and other resources. Stations, such as laptops, smartphones, and tablets, represent the devices that connect to a Wi-Fi network. Similar to Ethernet, each station possesses a unique identifier called MAC address. To recap, Wi-Fi based on the IEEE 802.11 standard has revolutionized wireless connectivity, allowing us to connect and communicate wirelessly with ease. As technology advances, the IEEE 802.11 standard will continue to evolve, bringing faster speeds, greater range, and enhanced security to Wi-Fi networks, enabling us to stay connected wherever we go.